Welcome to Maths Guru channel. Today we're going to deal with linear programming problems using the simplex method of maximization. The simplex method is one of the computer adaptable methods used in resolving programming problems involving two variables, more than two variables, or large numbers of constraints. It was developed by Agih in 1946. It provides us with a systematic way of examining the vertices of the visible region to determine the optimal value of the objective function. Here we have how to use the simplex method. Number 1. Standard form. A linear programming problem is in standard form if it seeks to maximize the objective function subject to the constraints. Number 2. The introduction of Slag variables. These are additional variables that are introduced into the linear constraints of a linear program to transform them from inequality constraints to equality constraints. So if a model is in standard form, the Slag variables will always have a positive 1 coefficient. That is to say, the coefficient must be equal to 1 and not less than 0. So the coefficient must be 1, not less than 0 or equal to 0. The third thing to consider is setting up the tableau. The tableau consists of the coefficient corresponding to the linear constraints variables and the coefficient of the objective function. This we are going to show while we resolve questions in this video. Number 4 thing to consider, check optimality. To check optimality using the tableau, all values in the last row must contain values greater or equal to 0. If a value is less than 0, it means that that variable has not reached its optimal value. So for any variable to reach its optimal value, it must be greater than 0. Number 5 thing to consider is to identify the pivot variable. The pivot variable is used in row operation to identify which variable will become the unit value and is a key factor in the conversion of the column, the conversion of the unit value. The column of the smallest negative value in the bottom row is the column of the pivot variable. Take note of this. I'm still going to make it clearer as we move on. To identify the pivot variable, divide the beta values of the linear constraints by their corresponding values from the column containing the possible pivot value. So if there is still a negative value at the baseline which may affect the x sub 1, x sub 2 or x sub 3 as the case may be, that is the variables in the constraint, the main variables in the constraints, then we have to repeat steps 1 to 5. But if there is nothing like that, then we can easily determine the values of the variables in the constraints. Here we have questions, likely questions that may be given to us to resolve. You can test this on your own, but for this video we're only going to pick the first question. When we resolve the first question, that will give you a guideline to resolve similar questions of this form. And then we shall attempt to resolve Kwara State Polytechnic Ilorin Institute of General Studies. We have a mathematics question here, that is Department of Mathematics. Okay. So before this, let's quickly take a look at the first question we have here. So we have it written here. The question is to maximize this z equal to x1 plus 2x sub 2. As stated in the steps involved in using the simplex method, we have the expression here, that is the standard form equation, which is telling us to maximize this to find the maximum value of z here. And the second step is to form a Slag equation from all these constraints we have. So for this first constraints, we are going to have 2x sub 1 plus x sub 2 plus the Slag variable, let's name it x1, equal to 8. Now we have converted it from this form to a Slag equation. So we have a Slag equation here. So for this one also, we're going to have x sub 1 plus x sub 2 plus the Slag variable equal to 5. All right, now we are going to take this standard form of expression here, we transform it into this form. So we are going to have something like this: z equal to x sub 1 plus 2x sub 2. So we collect x, all these unknown, to the the left hand side, and equate it to 0. By doing that, we're going to have something of this nature. x1 crossing the equation sign will become negative x sub 1. Then 2x sub 2 crossing the equation sign becomes negative 2x sub 2 plus the z equal to 0. So we have the Slag equations, and we have a standard equation here as well. So the next step is to set up a Tableau, and this Tableau is going to be a sort of matrix. Now we're going to have the coefficient of x1, x sub 1, x sub 2, x sub s sub 1, s sub 2, and z. We can actually neglect the coefficient of z here. It is allowed, we can do that. So, and this will become the beta value. We have a beta value here. So quickly we have to construct our table quickly. So we have a table this way: x sub 1, x sub 2, s sub 1, that is the Slag variable, the Slag variable 2, and the beta value, which we have as 8, 5, and 0. We have the coefficient of x sub 1 here to be 2, the coefficient of s sub 1 in the second equation to be 1, the coefficient of x sub 1 in the third equation here to be negative 1. Then the same thing we have the coefficient here to be 1, the coefficient here to be 1, 0. So we do not have okay, we have x sub 2 here. The coefficient is 1 as well. The coefficient of x sub 2 here is -2. Here we have s sub 1. The coefficient is 1. We do not have x sub 1 here, so we put 0. No x sub 1 here. We put 0. No slack variable there. So going to the column of the slack variable 2, we don't have slack variable 2 in the first equation, so we put 0. Here we have slack variable in the second equation, so we put 1. The coefficient is 1, and we do not have a slack variable in the third equation, so we simply put 0. So remember that we say the coefficient of the z value can always be neglected. So now we are going to check for optimality. To check for optimality, we have to just concentrate on the x1, x2 here, since our z equation is simply x1 plus 2x sub 2. So we are going to concentrate on this. Since we still have negative value here, all we need to do is to transform these things in such a way that we have everything here to be positive. Everything in this row, last row, to be positive. So let's better our table further. And to better our Tableau, all we need to do is to identify the pivot value here. And to identify the pivot value, all we need to do is to locate the column of the pivot value. The column of the pivot value we can identify by locating the most negative or the lowest number in this last row. The lowest number we have in this last row, and the lowest number is -2. -2 is less than -1, so it is the lowest. So here will be where our pivot value will be. Then how do we identify the pivot value? It's quite simple. All we need to do is to divide the beta value here by the corresponding value in the pivots column. So we have 8 divided by 1 to give us 8. That will give us 8. And 5 divided by 1 will give us 5. Since 5 is lower than 8, that is the result we're going to have here. We have 8 over 1, which is 8, and 5 over 1 equal to 5. So this is the row of the pivot value. So where it intersects with this will give us the corresponding pivot value. So it means 1 is the pivot value here. So we are going to construct another table now. So we can simply represent all these, the role here for the pivot value, put them 1, 1, 0, 1, 5. So our target is to make this 0 and to make this 0. So we have to manipulate on this data here. How can we make this 0 in relation to 1? We can simply say 1 minus 1 will give us 0. So we are going to say 2 minus 1 to give us 1 here. So we're going to do 2 minus 1, that is 1. 1 minus 1, 0. 1 minus 0, 1. 0 minus 1, we are going to have -1. 8 minus 5, we're going to have 3. Now, that is at the bottom of the pivot value here, we have -2. How can we make it 0 in relation to the pivot value? So we can simply multiply the pivot value by 2 and then add it to this. So we say 1 times 2, which is 2. 2 plus -2 will give us 0. Here we're going to have 1 times 2 also, which is 2. 2 plus -1, which will be equal to 1. 0 times 2, 0 plus 0, 0. 1 times 2, 2 plus 0, 2. Then 5 times 2 plus 2 plus 0, will give us 10. At this point, we still want to have our x1 known. So the smallest number we have on this row now is +1. That is this one. So here we are going to have our pivot value for another transformation again. And the same way we did with this, with the first Tableau here, is what we're going to do to this. To know our pivot value, we simply say 3 divided by this column, that is 3 over 1, which is 3, and 5 over 1 is equal to 5. Therefore, pivot value will be +1 there. So we are going to write the row of the pivot value as usual. We have 1, 0, 1, -1, and 3. So our target now is to make this row, this column or this cell 0, and this cell also to make it 0. Now, how can we make this 0 in relation to the pivot value here? We simply can say this one, the one we have minus the pivot 1, and that will simply give us 0. 1 down here minus 0 will be 1. 0 minus 1 will give us -1. And 1 minus -1 will be equal to 2. That is negative, positive. 1 plus 1 will give us 2. Then 5 minus 3 will be equal to 2. All right. Then how can we make this cell now to be 0 in relation to the pivot value? We can simply subtract the pivot 1 from this one down, so that will give us 0. 0 minus 0, 0. 0 minus 1 will give us -1. 2 minus -1 will be equal to 3. And 10 minus 3 will be equal to 7. All right, will be equal to 7. At this point, we have our x2, x1 corresponding to 3 here. That is the only positive one we have here. So 1x1 is equal to 3. And the x2, which is on the second column here, corresponding to the second row, we have 1 to 2. So x sub 2 will be equal to 2. So we have x sub 1 equal to 3, x sub 2 equal to 2. Now, to determine the maximum or to maximize z now, recall that max z is equal to x sub 1 plus 2x sub 2. So it will simply be, anywhere we see x sub 1 now we put 3, and anywhere we see x sub 2 we put 2. So we have 3 plus 2 into 2, and this will be equal to 3 plus 4, and that is equal to 7. So this is how to resolve this sort of problem using the simplex method. Now, let's quickly consider the question we have here. Just like the first question we resolved, the first thing to do here is to form a Slag equation. So for the first equation here, we're going to have the Slag equation to be x sub 1 plus 4x sub 2 plus Slag variable equal to 24. Then for the second one, we're going to have 3x sub 1 plus x sub 2 plus a Slag variable 2 equal to 21. Then the third equation there, we're going to have x sub 1 plus x sub 2 plus the Slag variable 3 equal to 9. And the z function, we have to collect it. Negative 2x sub 1, negative 5x sub 2 plus z equal to 0. All right, and we have x1, x2 is greater or equal to 0. So we can now move on. To create a Tableau, we have the column for the x sub 1, column for the x sub 2, column for the Slag variable 1, column for the Slag variable 2, column for the Slag variable 3, and the beta value. Let's simply fix the beta value first. We have 24, 21, 9, and for the z value, we're going to have this 0. Okay. For the first Slag equation, we're going to have the coefficient of x sub 1 is 1. The coefficient of x sub 2 in the first equation there is 4. The Slag variable is 1. No Slag variable 2, no Slag variable 3. Then the second Slag equation, we have the coefficient of x sub 1 to be 3, x sub 2 to be 1, Slag variable 1 to be 0, no Slag variable 1 there, and there is Slag variable 2, the coefficient which is 1, no variable 3. Now for the third equation, the Slag equation, we have the coefficient of x sub 1, 1, x sub 2, 1, and no s sub 1, that is the Slag variable 1, no slack variable 2, but there is slack variable 3, which is 1. All right, and for the z value we have -2, -5, the coefficients, and no slack variable 1, slack variable 2, slack variable 3. We can neglect the coefficient of the z value here. Now we are going to better our table. To do this, we have to locate the pivot's value, and to do this we have to first of all locate the column. And how do we locate the column? We trace the most negative or the lowest number in the bottom here, and which is -5. So here we have our column. So to know the pivot value, all we need to do is to divide the bet value by the corresponding values we have in the column for the pivot value to identify the one which is our pivot value. So 24 divided by 4, 24 over 4, which we're going to have 6, and 21 divided by this, divided by 1, we're going to have 21. 9 divided by 1, 9 divided by 1, we're going to have 9. So 6 is less than all of these. Therefore, this will become our pivot value. Now that we have identified our pivot value, all we need to do is to write the numbers we have on that pivot row. So we have 1, 4, 1, 1, 0, right? Okay, 1, 4, 1, 0, 0, 2, 4. Then our target is to turn all these to 0. So we have 1, 2, 3 to turn to 0. So for the first one, how can we turn it to 0 in relation to the first, the pivot value? All we can do here is multiply this by 4 and remove 4. Multiply this by 4 and remove 4. By doing that, this will be 0. So 4 times 4 is 0, right? 0. 4 times 1, 4, sorry, minus 4, 0. And then we have 3 times 4, which is 12. 12 minus 1 is equal to 11. 0 times 4 is equal to 0 minus 1 is equal to 4. 0 minus 1 is minus 1. Then 1 times 4, 4 minus 0, 4. 0 times 4 minus 0 is going to be 0, of course. Then we have 21 times 4 is equal to 84 minus 24 is going to be equal to 60. So we have 60 here. So for the second row now, let's come. How can we change this to 0 from here? Or we can simply do the same. We multiply this by 4 and remove the pivot value. So we have 1 times 4, which is 4, minus the pivot value is going to be 0. So we do the same for the other values there. 1 times 4, 4 minus 3 is going to be 1. 0 times 4, 0 minus 1 is going to be minus 1, of course. Then we have for, okay, under S2 now, 0 times 4, 0 minus 0, 0. Then we have 1 times 4, 4 minus 0, 4. Then 9 times 4, we're going to have 36, and 36 minus 24 is equal to 12. So we're going to have 12 here. Now for the last row now, how can we make this 0 in relation to the pivot value? So we can simply multiply the pivot value by 5 and multiply this value by 4, then do our addition. So 4 times 5 is 20, and negative 5 times 4 is negative 20. If we add it, simply we're going to get 0. So remember that all this row now we're going to multiply by 5, and we're going to multiply everything here by, so we multiply here by 5 and we multiply here by 4. Then we add together. 1 times 5 is 5. Negative, then the negative 2 times 4 is equal to negative 8. So 5 plus negative 8 is negative 3. All right, we are on Slag variable 1 now, column. So we multiply this by 5. 1 times 5, 5. Then 0 times 4, we're going to have 0. So if we add it, we're going to have 5 down. That is 5 plus 0 is going to be equal to 5. So the next is the column of x2. So we multiply this by 5. 0 times 5 plus 0 times 4, which is still going to give us 0. 0 times 5 plus 0 times 4 is still going to give us 0. And we are going to have 24 times 5. 24 times 5 is equal to 120. And then we have what's here? 0 times 4 is 0. So 120 plus 0 is equal to 120. So we have the table complete. But recall that we have not reached the optimal level for this value for this. We still have a negative at the column of x sub 1. So that is going to be the column again of the pivot value. It's going to form the column for the pivot value because it's the most negative or the lowest number we have there. So to better our Tableau now, we're going to construct another one. So we have to identify the pivot value now by doing the same thing we did from step 1 to 6 again. So we have 24 divided by 1, which is 24. 60 divided by 11, we have 60 over 11, which is 60 divided 11 will give us 5.45, approximately 5.5. Then we have 12 divided by 1, divided by 1, which is equal to 12. Therefore, the lowest is 5.5, and it means our pivot value is going to be 11. Oh, okay, you said something. All right, I got it. Okay, we have something here you said. Let's quickly retrace that and see. Okay, for this we say multiplied by 4 and remove this, so it's going to, it's supposed to be 3, right? All right, so this is supposed to be 3. We have 1 times 4, which is 4, minus 1, which is equal to 3. All right, I got it. Therefore, it means that this is going to change. So we have 5.5 and 12 divided by 3, which is 4. 12 divided by 3 is 4. Therefore, it's going to be the pivot value. So sorry for that. So I think we have been able to retrace where we made the mistake. Now we continue from there. We're going to better our table now. Okay, we have been able to locate our pivot value, so we simply put the values here. That is on the third row. We have 3, 0, negative 1, 0, 4, 12. So our target now is to make all these cells to be 0. How to transform the cell here such that it becomes 0 in relation to the pivot's value. So we can simply multiply this by 3, right? So multiply everything here by 3 and then subtract the pivot value. And in doing that, we're going to have 1 times 3, which is 3, and 3 minus 3 is equal to 0. 4 times 3 is 12, and 12 minus 0 is going to be 12. 1 times 3 is 3, then 3 minus negative 3, negative 1 is going to be 4. We have 0 times 3 minus 0, 0, 0 times 3, 0 minus 4, negative 4. Then we have 24 times 3, which is 72, minus 12 is equal to 60. Then let's move to the second row now. We're going to have okay, we have 11 here. How can we manipulate this to become 0 in relation to this? So we can simply multiply this by 3 and multiply this the column, row 3 by 11. Multiply row 2 by 3, multiply row 3 by 11. So we have 11 times 3, 33, and 3 times 3, we have 33 as well. So if we subtract, we're going to have 0. 0 times 3 is going to be 0, and 0 times 11, we're going to have 0. Subtract, we're going to still have 0. Negative 1 times 3 is equal to negative 3, and negative 1 times 11, we're going to have negative, that is a negative 11. So we're going to have negative 11, negative 3, minus negative 11, which is negative 3 plus 11. Negative 3 plus 11 will be equal to 8. Then the column for S2 now, we're going to have 4 times 3, which is 12, minus 0 times 11, which is still going to be 12. Then we have 0 times 3, which is 0, minus 44, which is going to be negative 44. Then we're going to have 60 times 3, which is 180, minus 12 times 11, that is 132. 180 minus 132 will be equal to 48. Then let's move to the last row now. How can we manipulate that to be equal to 0 in relation to the pivot value we have here? So we can simply add 3 plus negative 3 will be equal to 0. 0 plus 0, 0. Negative 1 plus 5 is going to be 4. 0 plus 0, 0. 4 plus 0, 4. And 12 plus 120 will give us 132. 132. Since we have everything here to be positive, then we have reached optimal level of value. Now we check x1 is only one value we have here, x2 is only one value, so it corresponds to the value we have. So we have x1, trace it, is equal to 12, then x2 corresponds to 16. But how do we determine the actual value for x sub 1 and x sub 2? It's quite simple. So we simply say how many value do we have in x sub 1? We have 3. That is 3 x sub 1 is equal to how many? 12. So x sub 1 will be equal to 12 over 3, which is equal to 4. And how many do we have in x sub 2? We have 12 x sub 2 to be equal to 16, and we have x sub 2 to be equal to 60 over 12, which will give us x sub 2 as 5. So it means x sub 1 is equal to 4 and x sub 2 is equal to 5. Now, to determine z value, the maximum value of z, now remember that in the equation we have z to be equal to 2x sub 1 plus 5x sub 2. So anywhere we see x sub 1, we put the value we have here, 4. 2 into 4 plus 5 into 5. Right? 2 times 4 is equal to 8, and 5 times 5 is equal to 25. and 8 plus 25 will give us 33. So Z is maximized at value 33. We can check the solution to see that it is correct by substituting the value we have in the Slag equation. Now, if you notice very well, we have 12 x sub 2 to be equal to 48, because everything except that 12 is 0 here. So 12, you can simply equate it, and 48 divided by 12, we're going to have 4. So if you substitute x sub 1, sorry, that is x sub 2 as 4 now, and x sub 1 as 4 as well, and x sub 2 as 5 into the, that is equation 2 now here, you will notice that it will be equal to the 21 we have there. That is to tell you that what we did here is quite correct. Thank you for watching Maths Guru's video. Don't forget to subscribe to our channel. Be blessed.